This missile costs about $3.2 million. This drone costs about $48,000. In a modern air defense engagement, the missile wins, and the side that fired it still loses. Here's the math that's quietly breaking air defense. Every defended base on Earth runs on the same quiet assumption, that the thing shooting at you is worth shooting down. For 70 years, that math held. The attacker's weapon costs more than your interceptor, or close enough that trading made sense. Cheap, mass-produced drones broke that assumption, and the people who design air defense know it. To see why, you need to look straight down, at the geometry of a single engagement. This is a one-way attack drone, the class everyone now copies. Propeller-driven, slow. A warhead bolted to a flying lawnmower engine. It cruises low, maybe a couple hundred miles, and it is built to be thrown away. That's the entire point. Open-source estimates put a unit somewhere between $20,000 and $50,000. A factory can stamp out hundreds. On its own, it's almost laughable. The threat isn't the drone, it's the price tag and the number you can build. Now the shield. A layered air defense sight is one of the most sophisticated machines humans build. Radar that sees 100+ miles. Interceptors that hit a target moving faster than a rifle bullet. Each of those rings is an engagement envelope. The volume where this system can reach out and kill. It works. It works extremely well. That's never been the problem. Here's the first crack. Radar needs line of sight, and the Earth is not flat. Watch what the terrain does. As the drone drops into this valley, the ridge masks it. The radar can't see through rock. It reappears here, seconds from the target, inside the inner ring, with almost no time to react. The shield assumed it would see the threat coming from far away. Cheap drones fly under that assumption. So the system does its job. One interceptor, one drone, clean kill. Tactically, a win. Financially, you just spent $3.2 million to destroy 48,000. You came out roughly 66-1 behind, and you won. One drone, you can absorb that, but nobody sends one drone. This is saturation. The tactic is simple and brutal. Send more cheap things than the expensive system can engage at once. 20 drones, maybe 40. They don't need to all get through. They need to cost more to stop than they cost to launch, and to make the defender run out first. Each launch tube reloads in seconds, but each interceptor is millions, and the magazine is finite. Somewhere in here, the defender faces the worst question in modern warfare. Do I spend another $3 million, or do I let this one hit? Let's run it. 40 drones, 50,000 each. The attacker spends $2 million. The defender, firing one interceptor per drone, spends $128 million. $2 million to burn 128. That is a 64-1 cost exchange, against the side with the better technology. Now repeat it. Next week. The week after. The attacker reopens the factory. The defender waits months for replacement interceptors that take a production line to build. You cannot win a war of attrition when every exchange bankrupts you. That's not a tactics problem, it's an arithmetic problem. The fix isn't a better missile, it's a cheaper kill. So the entire defense industry is now racing down market. Guns and Smart Fire Control recently demonstrated putting shotgun-armed defenders and computerized optics against drones at a US airbase. Nets fired by other drones. High-energy lasers that cost a few dollars a shot. Kinetic interceptors built to be affordable on purpose. The whole game is collapsing the cost per defeat, from $3 million down to thousands, down toward the price of the drone itself. Whoever wins the cost curve wins the drone war. The market for it is heading past $20 billion by 2030. For 70 years, air defense meant building something exquisite enough to stop anything. The drone didn't beat that. It made it too expensive to use. The next decade of warfare won't be decided by the best missile. It'll be decided by the cheapest one that works. If you want the geometry behind the headlines, subscribe. We map the next one.